What's up, guys? My name is Michael and welcome to my YouTube channel. Today we're going to talk about creating and using namespaces. So namespaces can be used to help you organize your classes, and they help programs avoid name crashes. So like having the same names when using one or more libraries. So today we're going to learn about how functions and classes are resolved by names, how to create a namespace, how to use a namespace, how to use a standard namespace, STD. So getting started. Name conflicts occur when a source of aggravation to both C and C++ developers. Name clash occurs when a duplicate name with matching scope is found in two parts of your program. So most common occurrence can be found in different libraries. So if you create like a container class with that, you declare and implement a list class, and then a list class is being used in a Windows library, then you want to maintain a list of windows for your application, but you still want to be able to use the list class found in the container library. So you can declare an instance of the Windows class list to hold your windows, and you could discover that the members functions you want to call are not available. So the compiler has matched your list declaration to the list class in the standard library, but what you really want to do is like use the list class for the Windows library. So namespaces here are reduce the chance of name conflicts. So namespaces are similar in some ways to classes, but the syntax is very similar. So items declared with the namespace are owned by the namespace. All items within a namespace have public visibility. Namespaces can be nested with other namespaces. Functions can be defined within the body of the namespace or defined outside the body of the namespace. If a function is defined outside the body of the namespace, it must be qualified by the namespace's name, or the calling program must have imported the namespace into its global namespace. Okay, so if the function can be defined so namespaces can be nested with other namespaces. Okay, functions can be defined within the body namespace. If a function is defined outside the body namespace, it must be qualified by the namespace name. So just like before, like std : if it's outside of it, you have to use std : Okay, so resolving functions and classes by name. The compiler parses source code and builds a list of functions and variable names. It also checks for the name conflicts. Those conflicts that it can't resolve are left for the linker to resolve. The compiler cannot check for the name clashes across object files or other translation units. That is the purpose of the linker. Thus, the compiler does not even offer a warning in this case. It is not uncommon for the linker to fail with the message identifier multiply defined. So when identifiers a name type, you could see this linker message if you have to find the same name with the same scope. Okay, so you get a compiler error if you redefine a name within the single file having the same scope. So when compiling together, this produces an error. Okay, so so they have the same scope. They create an integer variable and they have another integer variable, and this linker announces that integer variable already defined in first obj. Okay, so they had another. Okay, so they have the first. Okay, this integer variable doesn't matter because this is in this scope, but they had one integer variable here in first.cpp. Then they have another integer variable called integer variable and a second file called the second.cpp. So in second.obj, the integer variable integer value is already defined in the first obj. If these names are in the different scope, the linker and compiler will not complain about the duplication. It is also possible to receive a warning from the compiler concerning identifier hiding. The compiler should warn in the first.cpp that the integer value in main is hiding the global variable with the same name. So yeah, this doesn't cause an error. To use the integer value declared outside of main, you must explicitly scope the variable to the global scope. Consider this when it assigned 10 outside of main and not to the integer value declared within main. So here they had integer value 0 and then a second integer value, which is the same, redefining the global variable. Integer value equal 10 assigned to global variable integer value. Okay, so this, what does this : do? What does this do? Which assigns a value 10 to the integer value outside of the main and not to the integer value defined within main. Okay, so if you use : integer value equal 10, this assigns the value to this global value. Okay, it doesn't assign it to this. So this you do : integer value, it assigns it to the outside one. So that's pretty good handy. problem with two global integers defined outside of a function is that they have the same name and visibility and can cause a linker error. Okay, visibility of variables. The term visibility is used to designate the scope of the defined object, whether it is a variable, a class, or function. Although this is covered in day 5, organizing into functions, it is worth covering here briefly. So as example, a variable defined a variable declared and defined outside any function, file, or global scope. The visibility of the variable is from the point of its definition to the end of the file. A variable having block scope or local scope is found within the block structure. Okay, so we already talked about this. This is only defined, local scope is only defined within these brackets, right? Integer local scope. This is only defined here and within this brackets for main. And then this is another local variable which is defined only these into this block. And another local integer variable equal 30 is only defined in here, so this doesn't affect this. Yeah, and this global, yeah. The main cannot access the f's local variable, and okay, yeah. So we know that this main cannot access this local variable main in the f the local variable in f. Main cannot access this. It won't allow you. Okay. Main locally does not conflict with the local scope. Yeah, okay, so we already talked about that. Linkage. Names can have internal and external linkage. These two terms refer to the use and availability of a name across multiple translation units or within a single translation unit. Any name having internal linkage can be only referred to within the translation unit in which it is defined. For example, a variable defined to have internal linkage can be shared by functions within the same translation unit. Names having external linkage are available to other translation units. Okay? So here they have... Okay, wait. Let me reread that again. Any name having internal linkage can only be referred to within the translation unit to which it is defined. Okay, so for example, a variable defined to have internal linkage can be shared by functions within the same translation unit. Names having external linkage are available to other translation units. Okay, so this one is an external linkage, right? And this is an external linkage integer variable. The external variable defined on line 1 of CPP, first CPP, this. Has external linkage. Although it is defined in first.cpp, second.cpp also has access to it. The 2.js is found in both files are constant. The 2Js which by default have internal linkage. You can override the const default by providing an explicit declaration in 13.5 and 18. Okay, so this has external linkage, because I guess it's a global variable. It's the same thing as adding extern right here, if I recall correctly. Yeah, okay. The J's, on the other hand, are constant, and they have internal linkage. So this has internal linkage because it's constant. Is that right? Wait, let me see. The J's found in both files are constant, which by default have internal linkage. Okay, yeah. You can override the const default by providing an explicit declaration. So you could override the const J. So here they overrode the const J by using an extern. So now it has external linkage. Okay. And I think external means you have it has the available or name across multiple translation units or a single translation unit, which is defined. Okay, so I'm guessing they didn't even explain it that yet. Okay, so you could override the const by providing an explicit declaration like this. So then they had extern const int j equal to 10, And then now in the second .cpp, they could use the J because it's extern. They have access to it, I guess. So note that cout is called on line 5 with the namespace designation of std. When built, the example displays as follows: j is 10. Okay. So extern basically says other people can use this, I guess. It's kind of like public, I guess, during linkage. Okay. Yeah, so you could override the const by putting extern. Normally has internal linkage, and now you made it external. Okay, static global variables. The standards committee have deprecated the use of static global variables. Static global variables are declared as follows: static int equal to 10. The use of static to limit the scope of external variables is no longer recommended and might be considered legal in the future. You should now use namespaces instead of static. Of course, doing this, you need to know how to create one. Okay, so you could use static global variables to yeah, you could do that. You write static int static 10. I'm guessing this it limits the scope of the external variable. Is no longer recommended and might become illegal in the future. Okay, so this actually limits the scope of the external variable, so you can't use it. It's kind of like private. You must use namespace. Okay. Use is to limit the scope of it is no longer recommended. Okay, so yeah, this is kind of like private, but they don't use this. This is no longer recommended. Static int equal 10. It limits the external variable, the scope of external variable, so you only can use it in this file, I guess. Yeah, this is different from the static inside a class. That was a call from the class access, but this is different. This is using static global variables. They're very different. Okay, so it's better to use a namespace. So the syntax for a namespace declaration is similar to the syntax for a struct or a class declaration. First, apply the keyword namespace followed by an optional namespace name and then an open curly brace. The namespace is concluded with a closing curly brace but no terminating semicolon. Okay, so you do namespace window and this creates a namespace, and then you could do move and then class. The name window uniquely identifies a namespace. You can have many occurrences of a namespace. These multiple occurrences can occur within a single file or across multiple translation units. When this occurs, the separate instances are merged together by the compiler into a single namespace. The C++ library namespace std is a prime example for this feature. This makes sense because the standard library is a logical grouping of functionality, but it is too large and complex to be kept in a single file. The main concept behind namespaces is to group related items into a single named area. They provide a brief example of the namespace which spans multiple header files. Okay, so here they have a namespace of window that has move int x and int y. And then they have another header file in namespace window, this time with resize x and y. So as you can see, window namespace is spread across both header files. The compiler treats both the move function and the resize function as part of the window namespace. Okay, that makes sense. Okay, you could declare and define types and functions within namespaces. Of course, this is a design and maintenance issue. Good design dictates that you should separate interface from implementation. You should provide this principle not only with classes but also with namespaces. Okay, so good design dictates that you should separate interface from implementation. You should provide this note. Following demonstrates a cluttered and poorly defined namespace. I'm so confused how this doesn't, because I'm still wondering how this like prevents collision with names. I guess you could do, because you have multiple namespaces. I guess you could choose which one to use for which class. I guess for which code you want to use. I guess just like standard. Okay, so this is example a cluttered, poorly defined namespace. So they have other declarations, namespace window, other declarations and variable definitions. They have move, which is a declaration of of function declaration and then other declarations. Then they have the definition of move here, and then they do this specific routine. They have resize, and then more definitions. You can see how quickly a namespace becomes cluttered. The previous example is approximately 20 lines in length. Imagine this namespace for 4 times longer. So, defining functions outside a namespace. You should define a namespace functions outside the namespace body. Doing this so illustrates a clear separation of the declaration of the function and its definition. Also keeps the namespace body uncluttered. Separating the function definition from the namespace also enables you to put the namespace and its embodied declarations within a header file. Definitions can be placed into an implementation file. Okay, so you should separate the function definition from the namespace and put the declarations within a header file. Okay. The definitions should be placed in an implementation file. Okay, so here they have a namespace window that has the declarations. And then they have they have the definitions in this header file for this namespace, and then they implement the implementation in a separate source file, which like this void window : move, and they know which one it is because it has window and then : Adding new members. A new member can be added to a namespace only within the namespace body. You cannot define new members using qualifier syntax. The most you can expect from this style of definition is a complaint from your compiler. The following example demonstrates this error. So they have a namespace window, lots of declarations, and some code. Then they have int window, new integer in namespace. Sorry, you can't do this. Okay, so you can't add new members. This preceding line of code is illegal. Your conforming compiler issues a diagnostic reflecting the error. To correct the error or avoid it altogether, move the declaration within the namespace body. Okay, so you can't do this. You can't declare a variable outside of the namespace. It has to be inside the declaration, inside the namespace. When you add new members, you do not want to include access modifiers such as public or private. All members encased within a namespace are public. The following code does not compile because you cannot specify private. Okay, so namespace window, private, void move. Okay, so this doesn't compile because you can't make it private. All members encased within a namespace are public. Okay, that makes sense. So this won't compile. They're all public within a namespace. Okay, nesting namespaces. A namespace can be nested within another namespace. The reason they can be nested is because the definition of namespace is already a declaration. So as with any other namespace, you must qualify a name using the enclosing namespace. If you have nested namespaces, you must qualify each namespace in return. For example, the following shows a named namespace nested with another named namespace. So I have two namespaces, the namespace window and the namespace pane, and then a void size. To access the function size outside the window namespace, you must qualify the function with both enclosing namespace names. In this case, you need the following line to access size. Okay, so if you want to access size inside pane and this namespace is inside the window namespace, you have to do window : pane : size 1020 to access the size. Wow, okay. Using a namespace. Let's look at an example of how to use a namespace and the associated use of the scope resolution operator. In this example, all types and functions for use within the namespace window are declared. After everything is defined, any member function that were declared are defined. These member functions are defined outside of the namespace. The names are explicitly identified using the scope resolution operator. Listing 18.8 illustrates a namespace. Okay, so they have using a namespace, and then it's namespace window, and then they okay, so let's look at okay, so they have the members, the instance variables, the variables here. Then they have a class of pane, and then they have an instance variable here, a static variable, count, and yeah. Then to access all of those things in this namespace for window, they did window. Wait, where's count? Okay, so they do window : pane : pane to call this code for the constructor to initialize x and y. Then to call the destructor, they do this. Okay, wow. Then they define the size of the pane here from this code, and they define the move here, define the window here. Okay, and then they have a separate main here. Okay, so note that the class pane is nested inside the namespace window, which is on line 3 to 20. This is the reason you have to qualify the name pane with the window : The static variable count, which is declared in pane on line 16, is used as usual within the function pane : size. Line 26 to 32, notice that max x, max underscore x, max underscore y are fully qualified. This is because pane is in scope, otherwise the compiler issues an error diagnostic. This also holds true for the function pane : move. Also interesting is the qualification of pane : x and pane : y inside both the function definitions. Why is this needed? Well, if your function pane : move were written like this, you would have a problem. Okay, so the pane : x and pane : y inside both function definitions. You need both of them. Otherwise, pane : move, you would have this, and this is a problem because the compiler doesn't give you any issue of the message at all. The source of the problem is the function's arguments. So the function arguments is x and y. Arguments in x and y hide the private x and y instance variable declared within the class pane. So the class pane of, they have a class pane of x and y, and the x and y hides the instance variables right here. Into x and y hides the instance variables. The private x and y instance variable declared within the class pane. Effectively, the statements assign x and y to itself. Okay, so if you don't have the pane : x equals to x, then this would just assign the values to itself. It doesn't know like which x and y it would use. So that's why you have to put pane : x to show which instance variable you're using. So here they had pane : x equals to x. They could do that because of this is the class pane, right? And it tells them that okay, in the class pane you're going to use this this instance variable x, and you could set it as the value x. And I think it's because this whole thing is in this whole file. That's why you could access this x. I think so. Access this namespace. Okay. Using the keyword. The using keyword is used for both the using directive and the using declaration. The syntax of the using keyword determines whether the context is a directive or a declaration. The using directive. The using directive effectively exposes all names declared in a namespace to be in the current scope. You can refer to the names without qualifying them with their respective namespace name. Okay, so the using directive exposes all names declared in a namespace to be in the current scope. Okay, so you can refer to the names without qualifying in their public. Okay, the following example shows the using directive. Okay. Well, actually, above, I don't think the reason they're able to use pane : x, I think it's because this whole thing, the namespace, the window is everything here is public, I think, except the class x instance x and y. So I guess they could use x because of no, it's just the declaration. That's why they're able to do this. Okay, so about the using, it's namespace, the name of the namespace, then : and then value 1. You could use the values in your namespace like that. You could also do it like this, using namespace window, so then now you could have access to value 2. This is the same thing that we did for std, using namespace std. The scope of the using Directive begins at the declaration and continues on the end of the current scope. Note that value 1 must be qualified to reference it. The name value 2 does not require the qualification because the directive introduces all names in a namespace into the current scope. So the using directive can be used on any level of scope. This enables you to use a directive within block scope. When the block goes out of scope, so do all the names within the namespace. The following example does this behavior. Okay, so when the block goes out of scope, you don't have access to the namespace anymore. So here they have a namespace window with integer value 1, integer value 2, right? And they say using namespace window. And they have access to value 2 because the block is value 2 is the using namespace window is still within this block, within these brackets, these braces. And because of that, they could use value 2. They have access to value 2. But afterwards, you don't have access to the namespace anymore. So that's why they say value 2 equal 20. This creates an error. The final line of code in F parentheses value 2 is equal to 20 is an error because value 2 is not defined. The name is accessible in the previous block because the directive pulls the name into the block. When that block goes out of scope, so do the names in the namespace window. So if you want it to work on the final line, you have to fully qualify it. So you have to do window : value 2 equals to 20. The variables names declared within a local scope hide any namespace names introduced in the scope. So this behavior is similar to how local variables hide a global variable. Even if you introduce a namespace after a local variable, that local variable hides the namespace name. So consider the following example. So they have a namespace window, and they have integer value 1 and 2, right? Then they have integer value 2 equals to 10. Okay, then they say using namespace window. Then they print out value 2. The value of the function is 10, not 40. Okay, so because even though they print out value 2, value 2 is in the namespace in window, which is hidden by is in this window namespace, right? So when you do print out value 2, it doesn't print out 10. It prints out 10. My fault. It prints out 10. It doesn't print out 40. Okay. Namespace window has a value 2 have a value 40, right? And then in this function f, when you're using using namespace window and you print out value 2, it prints out this value 2. And the reason is because value 2 in window here is hidden by the value 2 in f. Okay, so whenever you're referring to a value, you're referring to the local one. That's what you're referring to. If you need to use a name within a namespace, you must fully qualify with the namespace name. Okay, so you would have to do the namespace name, which is window : value 2, and that would print it out. If you need to use a name within a namespace, you must fully qualify. Okay, so an ambiguity can arise using a name that is both globally defined and defined within a namespace. The ambiguity surfaces only if the name is used, not just when a namespace is introduced. Okay, so this is demonstrated in the code for it. So they have a namespace window, and it has value 1 equals to 20. Then they have using namespace window. Then they they create a global variable value 1 is equal to 10. Okay, that's just so confusing. Okay, never do this. Just don't do this. Okay, Then they have a function f, and they're setting value 1 equal to 10. Because which value 1 are they referring to? This one, the global variable, or are they referring to the namespace value 1? So this ambiguity occurs using the function f. The directive effectively brings value 1 from window into the global namespace. Because value 1 is already globally defined, the use of value 1 in f is an error. Note that the line of code in f were removed, no error would exist. So if you try to use value 1, you're going to get an error in f, because they're trying to bring the namespace window, so then you can have access to the value 1 in window into here, but value 1 is also globally defined. So when you try to use value 1, ambiguity occurs and they don't know which one you're using, so it gives an error. But if you remove value 1 equal to 10, no error occurs, which is weird. Okay, the using declaration. The using declaration is similar to the using directive, except that the declaration provides a finer level of control. More specifically, the using declaration is used to declare a specific name from a namespace to be in the current scope. You can then refer to the specified object by its name only. The following example it demonstrates the use of the using declaration. So they have a namespace window, has value 1 and value 2, and value 3, 60. So then, okay, so the using is similar to use, except that declaration provides a final. The using is declared to the specific. Okay, so using the using window puts it into a current scope. Okay, it's not like. So then you can refer to the object by its name only. So it's not like the same thing as like just using window : : okay. So if you use using, it puts it into the current scope. You can then refer to the object by its name only. Okay, so then when you put using window : value 2, you can now use value 2 from this namespace window. So this namespace window has value 1, value 2, value 3, right? And because they used using window : value 2, it brings value 2, which is 40 here, into the current scope, so then they could set value 2 equals to 30. However, to access value 1 and value 3, they have to use window : value 1 is equal to 10. And they have to use window : value 3 in order to set it to 10. So these have to be qualified. The using declaration adds a specified name to the current scope, so the declaration does not affect the other names within the namespace. In the previous example, value 2 is referenced without qualification, but value 1 and 3 requires qualifications. Okay, so yeah, that makes sense. That's what it does. This contrast with the directive bringing. This is different with the directive that brings all the names into the namespace within the scope. So this is different from using using window, using namespace window, and that brings all the values into the scope. Instead, here it just does using window : value 2, which only brings value 2 into the current scope. So now you could use value 2. Okay, after a name is brought into the scope, it is visible until the end of that scope. This behavior is the same as any other declaration. A using declaration can be used in the global namespace or within any local scope. So it is an error if you introduce a duplicate name into a local scope in which the namespace has been declared. The reverse is also true. The following example shows this. Okay, so if you have namespace window in a value 1, value 2, right, and you redefine value 2 equals to 10, and then you use you bring value 2 from the namespace window into your current scope, this is an error because it doesn't know which one to define. The second line produces a compiler error because value 2 is already defined. The same error occurs when using declaration is introduced before the definition of the local value 2. Any name introduced at local scope using a declaration hides any name outside the local scope. Okay, so this creates an error because you're bringing, this had value 2, right? The window had value 1 and value 2. Integer values, value 1 and value 2, right? Then here it has value 2. They redefine value 2 equal to 10. And then they say, okay, bring everything from windows into this, from all the values in window into the current scope, into this current block, right? And because value 2 is redefined, when you print out value 2, it gives an error. Any name introduces, okay, so consider this example. So this has value 1 and value 2 this time. And they declare value 2 again, this time globally. Then in the function f, they say using namespace, and using window, they bring value 2 from the namespace window. Okay. Then they print out value 2. This hides the value 2 defined in the global namespace. As mentioned, a using declaration gives you finer control over the names introduced from a namespace. The using directive brings all names from a namespace into the current scope. It is preferable to use a declaration over a directive because a directive effectively defeats the purpose of the namespace mechanism. A declaration is more definitive because you are explicitly identifying the names you want to introduce into the scope. A using declaration does not pollute the global namespace, as in the case with the using declaration. Directive, okay, as opposed to the using directive. Of course, you can declare all names found in the namespace. The name hiding, global namespace pollution, and ambiguity are all reduced to a more manageable level by using the using declaration. Okay, so here they redefine value2 this time as a global variable to equal 10. Now when they say, okay, I'm going to use the value2 from the namespace of window from here, I'm going to put that all into this local scope, right? That print value2, that actually prints out this value2 because it brought the code from namespace window value1 and value2 into the current scope within these blocks. So that's why it uses this value2. When you do using window ::value2 and you print out value2, it does this one. It hides the global variable value2. So it's different from the above here because this was an error. Okay. Namespace alias. A namespace alias is designed to provide another name for another namespace. An alias provides a shorthand term for you to refer to a namespace. This is especially true if the namespace name is very long. Creating alias can help you cut down on lengthy, repetitive typing. So consider the following code. So they have a namespace software company, and they have integer value. Then they had, okay, and then they said, using this namespace in the value software company, : value, they said equal to 10. And then they say namespace TSC is equal to software company. Okay. And they do TSC, the value equal to 20. Okay, so then this creates an alias called TSC, and then they set that equal to the software company. So then whenever they use TSC, it refers to this namespace of software company. That's what creating the alias means. Okay, the drawback is that your alias might collide with an existing name. If this is the case, the compiler catches a conflict, and you can resolve it by renaming the alias. Wow. Unnamed namespace. An unnamed namespace is simply that, a namespace that does not have a name. A common use of unnamed namespace is to shield global data from the potential name clashes between object files and other translation units. Every translation unit has a unique unnamed namespace. All names defined within the namespace, unnamed namespace, can be referred to without explicit qualification. Here there are examples of two unnamed namespaces. Okay, so the reason why we have unnamed namespaces is to shield global data from potential name clashes between object files and other translation units. So here they have a namespace. It's not named, and it has integer value, and then a character function that takes in a character pointer. So then now they have a second unnamed namespace in a second file called 2, and it has integer value and then a character pointer. Okay, then they have a character, and they call the function p, passing in, what are they passing in? Okay, in this case there are two listings that are compiled into the same executable. Each of the names, value, and function p is distinct to its respective file. To refer to an unnamed namespace within a translation unit, use a name without qualification. This usage is demonstrated in the previous example with a call to the function p within each file. This use implies a using directive for objects referred to from an unnamed namespace. Because of this, you cannot access members of an unnamed namespace in another translation unit. The behavior of an unnamed namespace is the same thing as a static object having external linkage. So having static int value equals 10, that's the same thing. Hold up. Okay, this is really confusing me. Okay. I'm still trying to learn this as well as you guys. Okay. The distinction. Okay, so we know that they have two unnamed namespaces with the exact same values in them. Okay. User's name without a qualification. To refer to an unnamed namespace name, use a translation unit, use the name without the qualification. This usage is demonstrated in the previous example with the call to function p within each file. Okay, so they called the function p within each file. What? To refer to an unnamed namespace name within a translation unit, use the name without qualification. This usage is demonstrated in the previous example with the call to function p within each file. Okay, so I'm guessing this calls the function p within each file. I don't know what pointer they're passing in though, but if you do this, it calls the function p in each file. Okay. This usage implies a using directive for objects referred to from an unnamed namespace. Because of this, you cannot access members of an unnamed namespace in another translation unit. The behavior on an unnamed namespace is the same thing as a static object having external linkage. Consider this example: static int value equal 10. Remember that the use of static keyword is deprecated by the standards committee. Namespaces now exist to replace code as a static declaration. Another way to think of an unnamed namespace is that they are global variables with internal linkage. Okay. So, unnamed namespaces, this means that they're global variables with internal linkage. So you could call this in this file, but you can't see them in other files. You can't see this namespace in another file. That's what I'm guessing. I don't think they would ever use this though in real life, unnamed namespaces. But hey, in the comment section below, guys, tell me, how does this actually call? What is this calling? Because they didn't even create a pointer here. This isn't really doing anything. This would be a compile error actually, because they didn't define char star ptr. At least I don't think they do. So yeah, in the comment section below, tell me what they're doing for this unnamed namespace. Okay, because they say it's like global variables with internal linkage. So I guess so. I guess you could do this, but I don't know what this is doing. Okay. Okay, so std has the standard namespace library. So we've been using this all the time, std, for cout and stuff. You can see this following hashtag include iostream using namespace std. Now you know that when you are using the directive in this manner, that it is pulling everything from the namespace. So going forward, you should consider it bad to employ the using directive when using the standard library. Why? Because doing so pollutes the global namespace of your applications with all the names found in the header. Okay, so if you do this every single time, you're polluting the global namespace of all your applications with all the names found in the header file. Okay, so it's actually bad if you do this. Keep in mind that all header files use the namespace feature. So if you include multiple standard header files and specify the using directive, then everything declared in the headers is in the global namespace. Wow. Okay, you might be noting that most of the examples in the book violate this rule. Yeah, okay, this action is not an intent to advocate violating the rule, but it is used for brevity of the examples. Okay. You should be using the using declaration instead. Okay, that makes sense. Okay. The correct way to use std namespace items. Okay, so the correct way is to do it like this. Using std, only use the code for cin. Using std, only use the code for cout. Using std, only use the code for endl. And then now you can use cout and endl. Okay. You could also use it this way: std : cout, std : endl, std : cin, std : cout. And that's the same thing. Okay. Qualifying namespace items in line might be appropriate for shorter programs, but can become quite cumbersome for any significant amount of code. Imagine having to prefix std : every time you do that in the standard library. Okay, so that's pretty much it. Yeah, I'll reread the summary for you guys, and then let's just see what that's it about namespaces. Creating namespace is very similar to a class declaration. A couple of differences are worth noting. First, a semicolon does not follow a namespace's closing brace. Second, a namespace is open, whereas a class is closed. This means that you can continue to define the namespace in other files or in separate sections of a single file. Anything that can be declared can be inserted into a namespace. If you're designing classes for a reusable library, you should be using the namespace feature. Functions declared within a namespace should be defined outside of that namespace's body. This promotes a separation in interface from implementation and also keeps the namespace from becoming cluttered. The using directive is used to expose all names in a namespace into the current scope. This effectively fills the global namespace with all the names found in the named namespace. It is generally bad practice to use the using namespace using directive, especially with respect to the standard library. Use declarations instead. A using declaration is used to expose a specific namespace item to the current scope. This allows you to refer to the object by its name only. The namespace alias is similar to this type def. The namespace alias enables you to create another name for the namespace. This could be useful when you're using a namespace with a longer name or a nested namespace. Every file can contain an unnamed namespace. An unnamed namespace, as it implies, is a namespace without a name. An unnamed namespace allows you to use the names within the namespace without qualification. It keeps the namespace's names local to the translation unit. Unnamed namespaces are the same thing as declaring a global value variable using the static keyword. Okay, so that's what unnamed namespaces are. Okay. Wow, okay. Rate, comment, subscribe. I'll check you guys later. Peace.